patience. I'm very sorry about that delay. I'd like to introduce myself. I'm Chris Fischbach, FMEA Mentor for 4607. I've been the FMEA Mentor for several years now. We're lucky enough to have FMEA and want to introduce the program to your teams to try to give you some tips and ways to get started, because it has had some wonderful benefits for our team. And I've got Ray here, who's going to be speaking to this, and she's the lead for our quality control group, who also manages FMEA.
Okay, so does anyone know what FMEA is?
Did anybody hear her? Speak up and speak up.
We can hear.
Okay. It's not working. Our slide's not projecting.
I can see your slides still. Do you just have to press presentation mode in the bottom of the PowerPoint? Would that work?
There we go.
There we go. It wasn't.
And then if you click the display settings and choose, I can't remember what the options are. Like don't duplicate or duplicate, because we can see your next slide coming. Yeah.
There we go. Thank you.
Yep, no problem. All right.
Okay, so FMEA is failure modes and effects analysis. It's looking for what could go wrong and how to fix those things so we can prevent them. So it is a part of our risk analysis program. So some examples, we all do this. So it's in our safety, we have a pit checklist, packing list, and just our SWOT analysis.
We also do FMEA.
So we look for preventing hazards for harm for our people, our business, team, our alliance, and our robot. So the FMEA team is cross-functional. Everyone does it. It's not just quality control. We have our engineers, our build team, programmers, electrical do it. And there are two different types of FMEA. There's design FMEA and process FMEA. So design FMEA is during the design phase. We focus on systems and not the whole robot. And it is to predict failures that could happen so we can eliminate them for during competition. So this is an example of our DFMEA.
Our DFMEA, we do in the design phase, as we said, and the DFMEA is what we do to predict anything that we could potentially see as an issue as we're building our robot. What we're doing at the DFMEA is, say we have our module, we will take the electrical module, take a look at it, have everybody in a room look at it and say, okay, how are we going to get our fingers through that part? These are a little too close, let's move them apart. What about arcing? Are we going to worry about arcing? So is that something that we need to do? And then we're putting that down as a spreadsheet. So this is an example of our spreadsheet there. And what we're doing is tracking for design. So that goes into a different metric, but we go by failure. What's the potential system that we're looking at? You know, if it's a manipulator, because we know that from year to year, we have different manipulators. So is it our climber? Is our oh gosh, I've been out for so long, I can't even remember our different manipulators, but is it a drivetrain, that type of thing. Then we go into our failure mode, and we're documenting our potential failures at that point, and we're assigning a rating for occurrence, severity, and detection. So that gives us our priorities so that we know where we want to focus in on. And then at that time, we're putting in our short-term and long-term actions and assigning it. You can see in the lower left screen there, our priority matrix that's kind of giving us that green is everything okay. That can kind of, you know, if we got time or budget, that's great. Yellow is something we want to focus in on, and red is something that we really want to focus in on. So those red things are really going to be our priority as we're going along. Those are the things that we better make our budget for and time for, and assign those and make sure that those get completed, because that's what we've determined is going to be our greatest potential for failure. Everything gets put on the spreadsheet.
So we have metrics to track our failures, so you can tell where the failures are coming from, or where they're projected to coming from, so you know which area you want to focus on. So we'll have these graphs so we can look at them clearly on where the failures will come.
We're looking on year to year too, trying to make sure that we're getting the failures addressed across the robot. We're of course focusing on mechanical, engineering design, and electrical at that point, but we also do cross over into getting our PIT checklist ready. So, and some of the programming. This is also a way to see how much benefit we are getting from the design phase. We put in several hours on looking at each of these modules. So it's nice to have this kind of a benefit and a way to show what we're putting into this. So that this is our kind of our eye candy on the metrics, showing year to year how we've benefited and how much work we've done.
So an example of what our design FMEA has done. So we activated our electric panel in 2019, and we compressed it into all electrical being in one box, so it's a lot more organized and neat.
You can see our draft robots. This is exactly February 2018 above versus our 2019 draft robot. We start out a little bit further ahead because we've had the issues addressed on our module, as well as our student learning, so that we have a little bit more to build on year to year, and that's what FMEA has provided for us.
So our other type of FMEA is process FMEA. It's the whole system, not just one part, and it includes supporting roles like the tools, corrective actions, pit crew, drivers, strategy. And it is corrective because you're correcting a failure that has happened. It's not predicting anymore. And it's focusing on eliminating repeating failures, so you're not just seeing the same failures over and over again. So you're just going to see improvement from it because you're going to be finding your errors.
We do this starting, you know, it used to be at BAG that turned over into process, but it's really once we get to the tournaments is when we turn over from our design phase into our process phase, because that's when we kind of say, this is our go button, we better be ready to present. And so we're no longer in the design phase. So then those get into our metrics and they count year to year.
So this is our spreadsheet for our FMEA. It's pretty much set up just the same as our DFMEA, on the same spreadsheet.
The only difference is the year on there. So the design says design on it, so it just goes into different metrics, but it's the same spreadsheet. You're filling out the same thing, so we have continuity, and it goes year to year, so everything on the spreadsheet is maintained. So we have all of the history of our team, all of our builds, all of our failures. So it's a kind of a summary of a notebook in the robot part of it, not just focused in on that. So I know notebook is a lot more than that, but and then this is our priorities. You can see clearly in these examples where we have the green, red, and yellow. So we knew where to focus in on once we were on our tournament. We were lucky enough last year to have, to be in the week 1. So we got our, we did get one tournament in. I know we're very lucky in that. So we do have examples of our 2020 robot in here. So those are some of our examples. You can see on there with the examples, we got our 5 whys. Actual, we had several with our manipulators. Our climber was actually new when we got into the tournament. So we had quite a few errors with that as we worked out a lot of these because timing was an issue for us, especially with being on week 1.
So from our FMEA, we make a pit checklist so that when we're at competition, we know what to check for failures. So this will help us have less failures during the competition season.
And as the robot comes back into the pit, the lead driver or the communicator, it depends on who that is. Often we have one person that's the point person to communicate anything that they saw on the field to the FMEA quality control person in the whoever's in that role. It can be a rotating role, but it's usually Ray in the pit. And that person would document on the checklist what the issue was. You can see an example there, and it's a miniature version of the FMEA. It gets copied into the spreadsheet later. But that person right then and there goes into what was the problem and the failure effect, and what are the 5 whys. And we'll go into the 5 whys a little bit later. And then what are our immediate correction, because that's all we have time to do in the pit. But we're gonna document that because as soon as we leave the tournament, memories are short. We forget what we did. So sometimes the change is to add it to the pit checklist. But then as we go along with the robot, we have the pit checklist, and you can see as we click them off, it will turn green. So we know exactly where we've been on the robot as we're going through and correcting some of the immediate issues. And then we've got things that are mitigating future errors by having them on the checklist. So.
Also with our pit checklist, we have graphs just like before. It just shows what our failures are coming from competition, and it comes from the FMEA that we put in.
We have the screen in front of our pit, and those of you that have seen us at tournaments will know that there's always a small crowd in front of our pit, and it's because we're watching the screen. It's our main way of communicating a lot of what's happening, because a lot of times in the crowd you see that the robot stopped or something happened, and this way they can come and see, okay, this is what happened, this is what we're finding out, and this is what we're doing about it. And then you can see how well we're doing with the metrics and where we're at with the today versus before. And then on the pit checklist, you can see some of them are green. This is a lot shorter checklist than we have now. We might be working on streamlining some of those things, but you can see that everything is green that we're working on. So the drive team knows where we're at, and if it's getting close, they can tell the team we're coming to time. And I see you're on the checklist at this point. Let's get moving.
So once you have checked all the things on the robot and everything's good, we have everything checked off. You can see there's a robot is ready for competition, and that's when we can take the robot out to the field. We can't take the robot out until it says that robot is ready for competition, so that we know that a robot is not going to fail for things that we didn't check.
Just another example.
So we have our 5 whys that is in our FMEA. So first we start what happened. So robot PCM was sticky fault from a short. So why is that? Because the circuit overloaded, causing a fuse to blow. So why did that happen again? PCM was not strong enough for our compressor. Why wasn't strong enough? Needed to replace PCM. And why? Because the compressor was not usable with PCM, which is because internal design compressor was eliminated.
So we found out through our FMEA that we had actually stopped at replacing the PCM. That gets a little pricey. So after the second one, we were like, why are we stopping there? So that was actually a failure mode investigation on our own FMEA. Why did we stop there, not at our fifth why? So we had to ask ourselves, why are we replacing this PCM? And the PCM was being replaced because the compressor was blowing out. And it turned out when we dealt with the manufacturer that they had changed it out. It was something that had been previously identified for them. So yeah, it turned out to be a good example for us, but not so fun at the time, that's for sure. Do we have any questions on the chat or anything we should be addressing? No? Okay.
So there are multiple types of corrective actions. There's elimination, which is just preventing recurrence of the issue. Facilitation, reduce the issue's frequency or probability of occurrence. Mitigation, reduce the severity of the impact on the robot. And inspection would inspect method to catch the issues that occur. So after our tournaments, we'll update our FMEA from our PIT checklist, and we'll go over it with our team, adding our severity, occurrence, and detections ratings for our priority number. We'll review each entry and short-term actions and agree upon a long-term action.
Yep.
The question on the 5 whys,
Yes.
and are they theoretical or are they something that we've come across as experience? We're asking these whys.
Every one of them is experience, and we're doing it in the pit. Can you think of a couple that we've done, or maybe go back to our examples? This is an example here that we did in practice. There's the 5 whys running right there. So the first why was we couldn't climb. Why couldn't we climb? We couldn't extend. Why couldn't we extend? The climber was not wound up right. Why wasn't it not wound up right? Number 4, it was ran down with our controller, but not by hand. The controller provided too much torsion. So then we had to add to our checklist, our short-term immediate correction action was to reset it, add it to the pit checklist to wind down by hand. So you can see in the green down in the corner there on our checklist is that we added it to our checklist there saying to wind it up by hand. So these are all real life examples for us, and it's something that everybody on the team has been trained to do. And sometimes we might stop at 3 depending on what it is, but the goal is to always hit 5. Oops, went too far. Any more questions on 5 whys? It's kind of the backbone of a lot of FMEA because it is so tempting to stop at 3. Anybody else? Can you guys read the chats? I can't see them. Feel free to ask any questions on chat and they'll let me know.
So although we review each entry for a short term and agree upon a long-term action of what we're going to do, we prioritize and assign long-term actions to people, so we know who's going to do it. So make sure everything gets done that needs to be done. And once the long-term action is completed, we'll update that on FMEA saying that we've completed the task.
And at this team, we're reviewing it as a team, not just the FMEA team. We're taking everybody. We've had comments from people in the media group actually before saying this is very interesting because we've seen problems. And if you can't tell what's going, okay, sorry, thanks. And so it's a way of communication and training for the entire group. We just had a chat question about if you can't see exactly what's wrong, do you still fill out the spreadsheet? Yes, we will put in the entry that we had a failure. You can think of an example of that. All the-
Well, the one with the climber, we added that one and we didn't know for a while why it was a failure, but we just put it in there and figured it out later, which we actually ended up figuring out later in a match. So
And, but we will enter it and we'll start the 5 whys. Sometimes the 5 whys will lead the team down a path that they wouldn't have gone through. So those details and just the taking the time to type it out and think it through is sometimes all the momentum that they needed. Because when you're in the pit, sometimes you're just in a hurry. You want to get it fixed. You want to get it back out. And so that's kind of that time to sit back and address the problem. Sometimes you're not going to have all the answers. We are going to document our immediate actions. The immediate action might be send it back out. Unfortunately, that has happened and it's going to happen. Sometimes our immediate action is incorrect. We all know that. We're doing the best we can. The pit team is learning as they go, but we document it. Otherwise, we're not going to have a traceable trail of what we did, why, and if something in the end isn't correct, how do we fix that? We need that trail so we know what steps we did and what buttons to push or unpush as the case may be. So does that answer that question? Great. Examples.
oh, so examples. So battery checks that we got started in 2018. We also added Loctite training, so we're not adding too much Loctite because that we found was an issue.
We added the pneumatic checks in 2019 to our spreadsheet. We have a separate tab on our spreadsheet. So before we send out our robot, we're checking the battery and we're checking the pneumatic system, making sure we actually have pressure and enough pressure to run our compressors that we need. And then the last one's your favorite. Quality control checks. You already answered that?
So our FMEA team reviews every failure immediately, asking 5 whys.
And in the tournament review, this is a summarization of really what our FMEA team does. We communicate, we prioritize, and communicate. This is our way of doing so and doing our short-term actions with our long-term actions. So the main part of that is updating and keeping the FMEA spreadsheet live. It does seem like it's a little bit of extra typing and work to do, but with that, that's our way of communicating. Again, strong word for us, and then keeping everything traceable. So we update our metrics year on year. We started this officially in 2018. What we did in 2018 was go back and sit down as a group with everybody and ask about what our errors were that they could remember over the years. So that's how we got prior to 2018. And then 2018 was kind of our development year, looking at more of a training and just documenting what some of the systems FMEA was that we could work on. And we do track it by drivetrain, manipulator, electrical system, and then down to the subcomponent for that. And we do track that from 2018 all the way through what 2020 season we had. And we're comparing our failure modes year on year and trying to bring those numbers down and acknowledging that mechanical is, of course, going to be the largest group because that's where it is on the tournaments. But we're trying to get that addressed and get them the support that they need, both in the pit and in the design phase, so that we're there. Our failure over the years is a fun pie chart that just kind of tells you what groups we've got and where we're finding those errors, so we know where to focus in our design FMEA for the next year. And that way we've focused in on our electrical module in 2018, as well as our PCM, and brought those failures down. We also noticed that we had Loctite issues year on year. We had rivet issues year on year. So we brought a lot of those mechanical numbers down by addressing those repeat errors. And that's what these metrics really help us provide. It's not just a pat on the back, which it is, but also it's a way of focusing in and prioritizing yet again without just the RPN number, which is looking at individual failures. This slide is really more about talking about that innovation cannot happen in isolation. Again, that is our motto. We on the left side, we've got our robot, our regulations, our rules, things that are our input. We can't do anything about those, but those get fed into our robot design. And from the robot design, we do our DFMEA. And then that goes into our robot build. And that goes out onto the floor with the tournament. So that's our robot outcome. That comes back from the tournament. Then we go into our FMEA analysis and we work on our improvements. That is fed into the team communication. And with time, ability, and budget, we all know that those are realities we all face. That gets fed into, and it's an everlasting circle at that point. We're constantly communicating. Continuous improvement is a huge way of handling FMEA, and we're going into that ever running circle with that. So that's what we're trying to show here.
So we have FMEA training. So what it is from each failure that we have, we're learning from it instead of just skipping over and be like, okay, whatever, we fixed the problem. We're actually learning from it and we can prevent it later. And since we're documenting it all, we can go and access that information later. So it's not just the lessons that we learned aren't just dying when the team's members graduate, because if you have a similar element, you can they can be like, oh, we did this year, and they can go and look at it definitely and see what potential problems that they could have, since it is similar. And it improves the overall quality of a robot because you're preventing things that could happen, so you're going to have more success.
Some examples that we've put in place of some training programs that we've done are the CAD training, wire training, soldering training. My favorite is the Loctite. We actually have a training module on Loctite, where to put it and where not to put it, and which to put on where.
So some of the benefits from FMEA are preventing and reactive. We are in control. We don't have as many failures that are surprising us because we're knowing that they might happen. And we know where to focus. We're not trying to watch for something that's rarely going to happen. We're looking for something that's more concerning. And so that makes a lot less stress because you know what you're supposed to be doing, which makes it a lot more fun. Communication, because of FMEA, you have to communicate, so it brings your team a lot better as a team.
We have media, marketing, but the business units, even coming into our FMEA reviews. So everybody has a voice in with the robot and everybody is driving together. So it is one point for us, I think, is one of the surprising points that I think that I didn't expect as much, is to bring everybody into the table.
With it, we've had a noticeable reduction in repeat errors since we are fixing them correctly because of the 5 whys, and we're seeing errors that could potentially happen, so we're preventing them, which leads to year-to-year improvement. We have a quicker pit time because we used to have try to get a bunch of stuff down in the pit that didn't need to be done, so it took a long time, but now we have our pit time about 5 minutes.
As you saw from the metrics, we have the metrics, we have communicating, and it's an acknowledgement of improvement. So we're already doing the work. Let's take credit for it. Everybody's doing the work. When you're in the pit, when you're on the field, when you're in the shop, it's really just documenting and acknowledging of that work. That's what our metrics are.
And again, we're increasing our communication, but within the pit, because we're saying what's happening, so everyone knows what's happening. It's not just one person who knows what's happening and is fixing it. We all know what's happening, so we all can help. With it, we increase our training because we know what we're having problems with, so we train someone in it. Like Loctite, we created that from FMEA because we realized that there was a problem and that people needed to know how to use it and weren't just using it without knowing how to use it.
We've actually Loctited movable parts before, so. And then we found this to be a continuity and succession planning. As Ray said earlier, you can go back and look on FMEA on what problems we had. This last year when we were doing our planning sessions on JUMP day one, we actually looked back and they were talking about a certain climber. We were able to look back and say, okay, we've had climbers before. What were our errors with that? And do we want a shorter base? Do we want this? Looking at the different options for ratings. And so that was able to be there. We had new students in there looking these up so that they were able, and they were learning as they were looking things up. And so we were training as we were planning, and everybody was involved in continuity. So that really works out well for us. 10 minutes? Okay, great, thanks.
We also have 5S. So we know what we put on the robot and what's gonna fail. We know what we need to bring. We're not bringing stuff that we don't need, so we're hauling a bunch of stuff around, and we're not forgetting things that we need because we know that that's on what we have on our robot. So we don't have too much stuff, and we don't have too little, so we can't fix our robot.
One time we went to an informal tournament for fun, and we actually brought in our robot on its cart and 2 cases. That was it. It was very fun to load and unload compared to a lot of people. We just skipped the whole line and just walked on out. And we had everything we needed. It was a lot of fun.
So this is our electric panel that we showed before, but you can see from our FMEA, this is what we got. It's all compact, so we don't have wire issues because there's not stuff getting in the wires, and everything is safe inside of the panel.
It's a dual layer, and everything is threaded through the top into the center and connected on the bottom. This took about 5 iterations. Our engineers were very patient and very willing to work. And I think that was one thing that everybody needs to be aware of, is when you're going through and you're criticizing, it's not an indictment on your work. It's really a betterment of it, and there's no pointing fingers. And that's one thing when we're doing the reviews, there's no names or anything. We're talking about the robot, we're talking about the actions, and it's a focus on the improvement part of it. So when we did this electrical panel, it worked several times and we got some great ideas out of it, and they put a lot of work in it, and we really want to acknowledge that because it was really a fine-tuning art there that they worked on.
Okay, so how can you start FMEA on your team? So you can start with the packing checklist, so you know what you're bringing and you don't have so much stuff, and you're not forgetting things, so you can't fix your robot.
Don't forget those bumpers. We've all done it. Safety inspection, sorry.
Yeah, this is supposed to be safety inspection. So what it is our safety captain has a checklist that she goes through, and it's just seeing that things that are in the shop or in the pit are safe. So she's making sure that machines have their shields on them, everyone has safety glasses on, there's no tripping hazards and stuff like that. We have our pit checklist. Just check for make a list of things you need to check for on your robot, like bolts, rivets, wires, so you're not stressing over what to check in the pit. Make a spreadsheet to write down your errors so you can track what's going wrong on your robot. And make a CAD so you can look at your robot before making it, so you're saving time and money for your team.
And having that quality control on the CAD helps down when we're building it so that somebody like Ray can come back and measure things to make sure that we're not going to have something mismatched later when we're trying to put our modules together.
You can find templates on our website.
And we've got our website on the next page, but when you're on the website, go to departments and drop down to FMEA. There's a couple different examples there. Maybe we can jump to it too after.
And if you need help, you can email us. There's our email.
And there's our website. So we have examples and spreadsheets that you can download for yourself. There's two examples there, one for just the 1 year and one that's ours, based on ours where it goes year on year. And then you can see our example, which is our live FMEA spreadsheet. It's all an open book. Go ahead and take a look and poke through all of our errors and see what our 5 whys really look like. And spelling errors and everything are on there. You have at it. So maybe we can go up. Do you have any questions? 4 questions? Oh, 4 minutes. Didn't leave you much time. Sorry about that for questions. Does anybody have any questions? So here's our spreadsheet. That's on the website. We have questions. We have our checklist. You can see examples here. And you can actually get to a simpler version of the FMEA as well as our full FMEA spreadsheet. So you can take these templates and download them and start a program if you would like. So you don't have to reinvent the wheel, or you can start and do anything you want, or go. A spreadsheet helps out immensely because you can't repeat what you don't know. If you don't know it, you can't track it. So I need a spreadsheet. What doesn't get tracked lies forgotten. Any chance? Yeah. The question is this a full-time job? We're inviting the entire team to the reviews, and the question is, I'm the mentor. I kind of set it up and train a lot of the, actually any new team members getting trained on it, and they sit in on the first meetings. And then, but Ray is the one who's driving this bus. So she is the one who's doing the quality control and entries with all that. And I'm more of an administrator and guidance at that point. I just kind of gave it the first push to move it. And Ray and the students go. We have several students that are highly involved, but as they rotate and stuff, we've got usually one on-point person. Do you have anything to add to that?
Yeah, like for me, it's more like I'm making sure that everyone's communicating and getting the FMEA filled out. I'm not just doing it by myself. I'm just there making sure everything gets done for the FMEA.
It sounds like quite a bit of time, and it's not. It's really an entry here and there once you get everything up and running. I think that's one concern I've heard repeatedly is we don't have time for this. And you get the spreadsheet going and you've got the actions out to several different students. They come back and you just remind them, enter it onto the FMEA. Everybody has access to this. So really what it is the minutes you're here or there. The time it took was getting that mentality built up for the students. And it's amazing now that they all are thinking about FMEA as they're building, as they're designing. And that's really where the benefits are. And this is more of the traceability aspect of it. I don't find it to be a huge lift anymore. And because of that, because we have so many students entering data here and there, and it's just a way of life now. Is our communication point though. She's our pivot person on that. Any other questions? Are we at time or should I wrap it up? Okay, thanks everybody. Oh, questions? How often do we have FMEA meetings, right?
During the design phase, we'll usually like once we have a CAD of the robot, we'll do it about once a week and just go over the design. And then during competition, we'll do one afterwards to go over the FMEA that we entered at competition.
So, and those design phase ones can be an hour to 2 hours, depending on what module we're looking at. And then at the tournament phase, it can get to be a couple hours at that point, but it's one time. So we'll have 2 or 3 during the season. Yeah. Any other questions? I don't want to run over time. I have no idea what time we're at.
We're at time.
Okay. Thanks, everybody.